So for today's session, we'll have another integration technique called trigonometric integrals. So basically, the integrands that we will consider here involve trigonometric functions. Okay, so these are the four things that will be included in this discussion. So we have the reduction formula, you have powers of sine and cosine, powers of tangent and secant, and other forms. So as you can see, you have powers of sine and cosine. Could be involving sine only or cosine only, but could be products of sine and cosine and their respective powers. And then same is true with the tangent and secant. Now, you don't see here powers of cotangent and cosecant, okay? But the technique, okay, for that pair, so powers of cotangent and cosecant will be the same as this bullet number 3 or item number 3. And then for other forms, you will have you will see that we will involve sine and cosine again, okay? And for that, instead of powers of sine or cosine, you will have different arguments for the sine and cosine. For example, you can have sine 3 theta times cosine 4 theta. So different arguments for sine and cosine. Okay, so that is the plan for today's discussion. Okay, so let us start with the reduction formula. So this involves powers of sine. So for example, you have here, if n is greater than or equal to 2, okay, the integral of sine x dx, this is equal to negative cosine x sine raised to the power n minus 1 x over n plus n minus 1 over n integral of sine raised to n minus 2x dx. Okay? So if you look at this is called reduction formula because, well, your first integral here, it involves power n. Okay? But upon computation using this formula, of course, this does not have any integral sign. So this is as it is. On the other hand, in here, you have another integral. But from power n, it went down to power n minus 2. So the power was reduced. So that's why it's called reduction formula. Okay? So the question is, how is this calculated? So from here, we write this as sine to the n minus 1x and then sine x dx. Okay? And then our u here, this will be your sine raised to n minus 1. So u, it's equal to sine raised to n minus 1x. And of course, du will be n minus 1 sine raised to n minus 2 x. And then by chain rule, multiply this by cosine x dx. Okay? And then, so this is our u. Our dv will be the remaining. Okay? The dv will be sine x dx. And therefore, the v, this is negative cosine x. Okay? So, what will happen to this? Using integration by parts, you have uv. Okay? So, uv, we have negative cosine x sine raised to n minus 1. Okay? sine raised to n minus 1 x. And then we have minus integral of v and then du. Okay? Integral of v du. So we will have negative. Then you have the quantity n minus 1 in here. And then sine raised to n minus 2x. You have the cosine in here. And you also have cosine in here from the v. Okay? So v du. Okay? So you have here cosine squared x dx. Okay? But cosine squared x, we need the following. Cosine squared x, this is equal to 1 minus sine squared x. Okay? This is equal to sine squared x. So if we have this, we will now replace the cosine squared x here by this 1 minus sine squared x. So in here we have negative cosine x, sine raised to n minus 1x. We have minus and minus, so that becomes plus. We have this n minus 1, which is just constant. So quantity n minus 1. Then we have the integral, sine raised to n minus 2x, while cosine squared x, it is replaced by 1 minus sine squared x dx. And then we'll just simplify this. Okay, we distribute the sine squared x over this difference here and then put the integral, of course. So you will have negative cosine x sine raised to n minus 1x plus n minus 1. Okay, let me write it like this, n minus 1 integral. So for this guy times 1, you'll just have sine raised to n minus 1 x dx. And then there's a minus in here. If you distribute it to the other side, so you'll get minus n minus 1 integral of sine to the n x dx. So again, that n minus 1 here, it was distributed. That's why you have this and this. You have minus here. That's why you have a minus here. And sine raised to n minus 2 times sine squared. That's your sine to the n. And notice you have sine to the n in here. You also have sine to the n in here. So integral of sine to the n dx, sine to the n x dx. You also have something integral sine to the n x dx. But the coefficient here, it's n minus 1. While in here, the coefficient, it's 1. So they are not the same. So remember the technique when we have to put this something like this to the other side of the equation. We will do the same thing in here. So what will happen? If we bring this to the other side, we will have integral of sine to the n x dx. So bringing this to the other side, it becomes plus n minus 1 integral of sine to the n x dx. This is the left-hand side. The right-hand side in here, you'll just copy this and this guy. And therefore, you will have equals. So here, minus cosine x sine raised to n minus 1 x plus n minus 1 integral of sine to the n minus 2. It should be minus 2 in here. Sine to the n minus 2x dx. So this guy here should be n minus 2. Okay? Questions so far? Yes?
Yeah, so
Riyadh, yeah.
yeah, isn't it supposed to be uh, a plus for before the n minus one, like the
Yeah, this one is plus.
no, I'm talking about the line in
In here, it should be
yeah.
minus because there's minus in here.
Oh, okay. All right. Thanks.
This should be minus.
Thanks.
Okay? Other questions? Are you good, Riyadh? Riyadh?
Yeah. Thanks.
Okay, Sophia?
So the step right above the last one, is that meant to be like a continuation of the line above?
Yes, this
Oh,
guy and
okay.
then until this guy.
Okay, thank you.
You're welcome. Okay. And then from here, other questions? And then from here, okay, you just combine this guy and this guy. You have sine to the n x dx plus n minus 1, integral of sine to the n x dx plus n minus 1 integral sine to the n x dx. If you combine this, you'll just get n, okay? So n integral of sine to the n x dx. That's for the left hand side. And of course, for the right hand side, it's just this guy. So minus cosine x sine to the n minus 1 x plus quantity n minus 1 integral sine raised to n minus 2x dx. Okay? And dividing by n, you'll get this formula here. Okay? Question? So reduction formula, it's just, you can just, at least for this function, you can just use your integration by parts. Okay? Now, if, of course, you will continue doing this. If your n is large, okay, you'll continue doing this. Okay? Now, if your n is even, if your n is even, there will be a point where you will just have integral of dx. You'll just get sine to the 0. Okay? And then if your n is odd, you will end up here at some point, you will end up here integral of sine x dx. And we know the integral of sine x dx. Okay? So it's a reduction formula. If n is large, you can continue working on this, okay, over and over again, until at some point you will reach integral of sine x dx or integral of dx. Okay? Questions? Your hand is raised, Sophia. Is that from before?
Yeah, sorry.
Okay. So that's for the reduction formula of integral of sine to the n x dx. Let's look at another here. So in here we have integral of tangent to the n x dx. So it's equal to this guy here. Tangent raised to n minus 1 x over n minus 1 minus integral of tangent to the n minus 2x dx. Okay? So in here, this is only our restriction. N cannot be 1. Okay? So n cannot be 1. Of course, when n equals 1, you already have a formula. Okay? But the reason why we are doing this is because of the appearance of n minus 1 in here on the denominator. Okay? So how do we prove this? So what we're going to do is to write tangent to the n x dx as integral of tangent to the n x, tangent to the n minus 2x, and then tangent squared x dx. Okay? And then for this guy here, we will use the identity tangent squared x equals secant squared x minus 1. So you will have to remember this integral or this identity here from your sec 4 or sec 5. One of the Pythagorean identities. So from here, we will now write tangent squared as secant squared minus 1. So that we will have the integral of tangent squared, tangent raised to n minus 2x times secant squared x minus 1 and then dx. And then let's just distribute this. Okay, let's just distribute this over that difference. This will give us integral of tangent raised to n minus 2x secant squared x dx. Okay, minus integral of tangent to the n minus 2 x dx. Okay, so far so good. And then for this, you look at this. For this, all we need to do is to integrate by parts. Actually, not integrate by parts. We'll just do a substitution rule. We can let u be equal to tangent of x. And then du, that's secant squared x dx. So you have that secant squared x dx that will become du. And of course, tangent raised to n minus 2x, that just becomes u raised to n minus 2. So you will have integral u raised to n minus 2 and then du. Then here minus integral tangent raised to n minus 2x dx. So if we integrate this, we'll just have u raised to n minus 1 divided by n minus 1. Then minus integral of tangent raised to n minus 2 x dx. Then finally, we bring back this tangent x. Okay? We'll end up with the formula here. So tangent raised to n minus 1 of x over n minus 1 minus integral of tangent raised to n minus 2 of x dx. And that is the reduction formula for tangent to the n. And again, reduction formula because from tangent to the n, after doing this, you'll just get tangent raised to n minus 2. So the power of tangent has been reduced. Yes, question, Florence?
So in a test or an exam, if we just wrote like the reduction formula of tangent, and then we wrote it out, and then we like did it, would it work, or would we have to
Oh
like
yeah,
show each
yeah.
step
You can
right now?
use them as it is. Like you just apply this. It's
Okay.
totally fine.
All
Unless,
right.
of
Thank you.
course, I'm going to ask you to prove it yourself. Okay? Other questions? For example, in here, integral of secant to the nx dx. Okay? So you will have tangent x secant raised to n minus 2x over n minus 1 plus n minus 2 over n minus 1 integral of secant to the n minus 2x dx. Again, your n here should not be equal to 1. And the reason why it's restricted that way because you have this n minus 1 on the denominator. Okay? So for this, I will leave this guy here as an exercise. Okay? So I want you to prove this formula. Okay? And maybe the technique would be integration by parts. You'll just have to think which identity from the trigonometric functions you're going to use, or how you're going to decompose this secant to the n. Okay? So try to work on the derivation of this reduction formula for secant to the n. Okay? Now, let us now consider integrals of this form. So powers of sine and cosine. So you have the integral of sine to the mx cosine to the nx dx. Okay? So all throughout in this slide and the next few slides, m will be the power of sine, n will be the power of cosine. So first condition, if the power of m is odd, okay, if the power of m is odd, then m minus 1 will be even. Okay? And therefore, what we're going to do is to write sine to the mx as sine to the m minus 1 x times sine x. Okay? And because m minus 1 is an even number, m minus 1 is an even number, you can transform this sine raised to m minus 1x into in terms of cosine. Okay? So to do that, you just have to do this. So you have sine squared, okay, sine squared x. You raise it to power m minus 2 to m minus 1 over 2. Take note that m minus 1 is even. Okay, it means m minus 1 is divisible by 2. So this guy here, this will just be an integer. Okay? Okay? And therefore, this sine squared x, replace it within terms of cosine. You have 1 minus cosine squared x. Raised to m minus 1 over 2, of course. And then you have here your sine x. And then, you can now let u be equal to cosine x. So this guy here, you will have 1 minus u squared raised to this. Okay? And then, of course, if you get du, that's just sine x. Or negative sine x, whichever is the correct one. Derivative of cosine, that's negative sine. Okay? So from here, okay, for example, let us illustrate the method. you have sine cube of x cosine to the fourth of x dx. The power of sine, it's odd. It's just 3 here. So what we're going to do is to rewrite this as the integral of sine squared x, and then you have your sine x, and then you have cosine to the fourth power x, and then dx. And in here, we just have sine squared, so we're good. If you go back to this, we need that sine squared because we are going to transform it to in terms of cosine. Okay? But that's just sine squared x here. There is no power, so that's totally fine. What we're going to do now is to transform that sine squared x as or into 1 minus cosine squared x. And then I'll just attach cosine to the fourth here. And then the sine x, I'll write it just before the dx. Okay? And we now have u be equal to cosine x, du, this is negative sine x dx. Correct? Okay? So, from here, we will get integral of 1 minus u squared, and then here you have u to the 4, and then du. Oops, there is a negative, so let's put the negative here. So there's a negative outside. Let's just put the negative outside. Or we can distribute that negative together with the u to the 4. So you will have u to the 6 minus u to the 4 quantity du. And this guy here, you can integrate easily. So this is just u to the 7 over 7 minus u to the 5 over 5 plus c. If we bring back cosine, we have cosine to the 7 of x over 7 minus cosine to the 5 of x over 5 plus c. So this is the answer. Yes, question?
Yes, sir. Isn't it u to the fourth minus u to the sixth?
Because of this negative here, we also
Oh,
distributed it.
u.
Yeah.
Okay. All right. Perfect. Thanks.
Okay. Other questions? Okay. Let us look at our next example in here. So you have sine to the 5x, square root of cosine x. So the power of sine in here, it's again odd. So we'll take out one of the signs. And we will have sine to the fourth x, then sine x, and then square root of cosine x dx. Okay? And then sine to the fourth x, we will write it as sine squared x squared. Okay? And then I'll write next to this square root of cosine x. And then I'll write sine x before, just before the dx. And then in here, you see, you have sine squared x. You can now change it into 1 minus cosine squared x Then you have the squared there. Then square root of cosine x, and then sine x dx. And then from here, again, you can now have u equals cosine x du. This is negative sine x dx. Therefore, we will have negative integral of 1 minus u squared squared. And then instead of square root of x, cosine x, so you'll have square root of u. But I'm gonna write it as u raised to 1/2. And then you have the du. And then for this, I'll just expand this. You have 1 minus u squared squared. We have negative integral 1 minus twice u squared plus u to the 4. Then u raised to negative 1/2 du. And then we can distribute the negative here. Also, u raised to negative 1/2. So we will have the integral of negative u. So to the 4 raised to, so u to the 4 times u raised to 1/2. So this becomes raised to power 9/2. And then plus 2, you have u squared times u raised to 1/2. That's u raised to 5/2. Then minus u raised to 1/2. Then close quantity, we have du. And then we are now ready to integrate this. So I hope you practice your power rules for integration, etc. And this guy here, if we integrate, we will have negative u raised to 11/2 over 11/2 plus 2u raised to 7/2 divided by 7/2 minus u raised to 3/2 over 3/2 plus the arbitrary constant c. And then we bring back cosine. So this is just negative 2 cosine raised to 11/2 x over 11 plus 4 cosine raised to 7/2 x over 7 minus 2 raised to 2u, sorry, 2 cosine raised to 3/2 x over 3 plus the arbitrary constant c. So this is the final answer. Okay. Question, is that from before? You raise your hand. So how did we get 5 raised to 5/2 in here? You have u squared u raised to 1/2. And then u squared, that's u raised to 4/2 u raised to 1/2. So you just add u raised to 4/2 plus 1/2. That's u raised to 5/2. Okay. Other questions? Okay. So again, this is the case when m is odd. The power of sine is odd. Now, what if we have the power of cosine? So if n is odd, then you have n minus 1 even. So this time, instead of working on sine, you work on cosine. Same process. Okay, same process. And in the end, what you're going to do is to change the cosine to in terms of sine. And once you've changed all the cosines in terms of sine, except for one cosine which you will take out from cosine to the nx, you will now do the substitution u equals sine x. So it's the same as in the previous case, okay? But this time, the power of cosine is odd. Okay? So for example, in here you have cosine to the fifth power x cosecant squared x dx. Okay? Now, we were talking about powers of sine and cosine, and then we have this cosecant. Just recall that cosecant of x is just 1 over sine x. So in here, you'll just have integral of cosine to the 5x over sine squared x dx. Okay? So the power of cosine, it's odd. Okay? The power of cosine, it's odd. So we use that method. What we're going to do, we take out one of the cosines. Okay? So we will have cosine to the fourth x and then cosine x. Then here we have a denominator sine squared x. And then the dx. And then from here, cosine to the fourth x, we'll just write it as cosine squared x squared. Then I'll put the sine squared here. And then I'll separate this cosine. I'll attach it or I'll write it right beside the dx. So we have here cosine x dx. And then now we are ready to change this cosine squared x into something in terms of sine. We will have 1 minus sine squared x quantity squared divided by sine squared x. And then you have your cosine x dx. So we let u be equal to sine x du. This is equal to cosine x dx. Therefore, we will have here integral of 1 minus u squared squared over u squared and then du. We just expand 1 minus u squared. We'll have 1 minus 2u squared plus u to the 4 divided by u squared du. Or we can write this as 1 over u squared minus 2 plus u squared quantity du. Okay? Or further, let's just write this as u raised to negative 2 minus 2 plus u squared du. Okay? And now we are ready to integrate. This is now u. So after integral or after integrating, we'll have u raised to negative 1 over negative 1. That's minus 2 plus 1. That's negative 1. That's why we have here negative 1. And then minus 2u coming from here. And then plus u cubed over 3 coming from here. And then plus the arbitrary constancy. And now we bring sine x back. This is just, instead of u raised to negative 1, I'll write that as 1 over u. And bring sine x. So this will be 1 or negative 1 over sine x. minus 2 sine x plus sine cube x over 3 plus the arbitrary constant c. Okay? Question. Now, what if both sine and cosine have even or have odd powers? Well, any of the first two methods here work. If the power of cosine is odd, you can do this. Or if the power of sine is also odd, you can do this. So
Sir?
just choose.
Sir,
Yes,
can you go back to the previous example, please?
this guy or a previous one?
Perfect. Thank you, sir.
Okay. Okay. So again, if the power of sine and cosine are both odd, you can choose any method. Just convert one of the functions into in terms of the other. Okay. And then you do the method. Okay. But the problem here now is what if both powers are even? So this is the third case. What if both powers of sine and cosine are even? If that's the case, we use these identities. Remember that cosine squared, you can also write it this way. 1 plus cosine 2x over 2. And then sine squared, you can write it as 1 minus cosine 2x over 2. So you need to remember this. So if both powers are odd, both powers are even, you convert each of them using these identities. And in the end, you will just have powers of cosine. In fact, powers of cosine 2x. And then from there, you'll just use the method number 2. Okay? Or if not, you can continue using this until you're done with until you can integrate it using simple substitution or so. So let's try to illustrate this. Let's try to illustrate this part here. We want to integrate cosine to the 4 sine squared. So cosine to the 4x sine squared x dx. So first, we write cosine to the 4x as cosine squared x quantity squared. And then the sine, well, let's just write it as this. It's still sine squared x. And then using the identity here, using the identities here, this guy will be transformed into quantity 1 plus cosine 2x divided by 2 quantity squared. And then for this guy, we'll just have 1 minus cosine 2x over 2. And then you still have the dx. Yes, question. Your hands is raised, Vian.
Oh, sorry, it's from the last time.
So from here, all we need to do is to expand this product. Okay. So for this guy, we will have 1 plus 2 cosine 2x plus cosine squared 2x all over 4. And then we have quantity, multiply it to 1 minus cosine 2x divided by 2 dx. And then we multiply further. So in here we will have, I'll have 4 times 2 on the denominator. So we'll get 1 over 8. And then we have the integral. Here we have 1 times 1, that's just 1, plus 1 times negative cosine 2x. So we'll have minus cosine 2x. Then here you have plus 2 cosine 2x times 1. So plus 2 cosine 2x. And then 2 cosine 2x times negative cosine 2x. So minus 2 cosine squared x. Oh, sorry, cosine squared 2x. And then here cosine squared 2x times 1. So plus cosine squared 2x. And then cosine squared 2x times negative cosine 2x. So minus cosine to the third power 2x. Close quantity, we have the dx in here. Okay? Okay? And then we'll just expand. We'll just combine this. So there was a question here, couldn't we just multiply the denominator by 2 to match the denominator of the first fraction? And so what if we multiply that? We are multiplying this. So you multiply the numerator by the numerator. You multiply the denominator by the denominator. We are not adding them or subtracting them. This guy here times this guy here. So we don't really care if they have matching denominators or not, because we'll just multiply numerator to numerator and denominator to denominator anyway. Okay, so we simplify this. We have 1 over 8 integral of 1. And then this guy here minus cosine 2x plus 2 cosine 2x, so plus cosine 2x. Here you have minus 2 cosine squared 2x plus cosine squared 2x. So we will have minus cosine squared 2x. And then here we just have minus cosine cube 2x. Quantity dx. Okay? Of course, integral of 1, you can do that easily. Integral of cosine 2x, you can also do that easily. Here we have a power of 2 for cosine x. We use again this type here, this kind of method. Here we have an odd power of cosine. We use the method in the second item. Okay? So let's do that. First, let us do this part here. We have the integral of cosine squared 2x dx. So I'll just put here aside And then this guy here, we will now have 1 minus or 1 plus cosine 2 times 2x. So this is cosine 4x over 2 dx. Okay, following. So again, from before, you have cosine squared x. This is 1 minus or 1 plus cosine 2x over 2. Now, instead of x, you have 2x. So you have 2 times 2x. That's why you have 4x in here. Okay? And from this, we have now 1 half, and then we integrate 1 plus cosine 4x because it's easily integrable now. You'll just have x, and then plus sine 4x over 4 plus arbitrary constant c. Okay? So this is for that part. Okay? For this part, let's work on that. You have the integral of cosine cube 2x dx. You write this as the integral of cosine squared 2x cosine 2x dx. And therefore, you can change cosine squared 2x into 1 minus sine squared 2x. Then you have cosine 2x dx. And then in here, you can let u be equal to cosine 2x. Du will be negative 2 sine 2x dx. Okay? Sorry, why is that? I let u be equal to sine 2x. My bad. So in here, I will let u be equal to sine 2x. And the du is 2 cosine x. 2 cosine 2x dx. Okay? So this guy now becomes integral of 1 minus u squared over 2 du. Following? Take note of that over 2. It's because we have the 2 in here. So this guy here we can integrate easily. So we will have 1 half quantity u minus u cubed over 3 plus again c. Let's say c sub 2 in here. Here we have c sub 1. And therefore, we can bring now sine 2x back in here. Okay? But let's bring that when we write the answer in here. So, we will have 1 over 8 times integral of 1 dx, that's just x, plus integral of cosine 2x dx, that's just sine 2x over 2. Then minus integral of cosine squared 2x, it's this guy here. Okay? So we will have 1 half times x plus sine for x over 4 plus c sub 1. But the c sub 1, I will attach it later. Or I will just combine all the c's. and then minus integral of cosine cube 2x. Okay, we have this. So minus 1/2 times u, that's sine 2x there. And then minus u cube. So sine cube 2x over 3. Okay? And then we just close the parenthesis. And then we will have our final answer. Parenthesis in here, another parenthesis in here, and then your plus arbitrary constancy. So this is the final answer to that integral. Okay? Now, take note that you can do this within this solution in here. Okay? And also this within this solution in here. I separated them so the solutions will be clear. Okay? So there was a question, why is cosine 2x equals... No, we integrated cosine 2x. The integral of cosine 2x, that's sine 2x over 2. Okay? Questions? Okay? So again, that's the method. If you have even power for cosine and for sine. Okay? Questions? Now let's look at the integrals of the form integral tangent to the mx secant to the nx dx. So in here, all throughout, your m, it's the power of tangent. Your n, it's the power of secant. So first, if the power of secant is even, okay, if the power of secant is even, n is even, n minus 2 is also even. Okay, so what we're going to do is to extract secant squared. So we will decompose secant to the n x into secant to the n minus 2x secant squared x. And since n minus 2 is even, we'll convert secant to the n minus 2x, okay, into tangent. Okay? N minus 2 is even. You can write secant raised to n minus 2x into this form. Secant squared x raised to n minus 2 over 2. Okay? And of course, you still have this secant squared x at the very outside. And then this secant squared x, you convert it into in terms of tangent. So everything in here, everything will be in terms of tangent except for the secant squared. So you expect your substitution should be u equals tangent of x. That will be our substitution. Okay? So if the power of secant is even, extract a secant squared, and then convert everything else to in terms of tangent. And then use the substitution u equals tangent x. For example, if we have here tangent squared x secant to the fourth x dx, we want to integrate that. So power of secant, it's even. So what we're going to do is to extract secant squared. So we will have integral of tangent squared x and then secant squared x times secant squared x dx. The first or the second secant squared x here, we'll attach it to dx. The rest of the secant, okay, in particular in this, you have secant squared. We convert this into tangent. So we will have integral of tangent squared x times 1 plus tangent squared x, and then you have secant squared x dx. And from here, we now let u be equal to tangent x du, that's equal to secant squared x dx. Therefore, this is just u squared times 1 plus u squared. We integrate that with respect to u. Or this is just the integral of u squared plus u to the fourth power du. And so, integrating this, we will have u cubed over 3 plus u to the fifth power over 5 plus c, or we have tangent cube x over 3 plus tangent to the fifth power x over 5 plus the arbitrary constant c. So we have this. Okay? Questions so far? So could you explain how you got 1 plus tangent squared x dx? It's an identity. It's an identity. You start with, you have, at least you should know this cosine squared x plus sine squared x equals 1. Okay? So what you're going to do is to divide everything by cosine squared. So you will have cosine squared x plus sine squared x divided by cosine squared x. This is equal to 1 over cosine squared x. So in here, you have cosine squared x over cosine squared x, that's just 1, plus sine squared x over cosine squared x, that's your tangent squared x. And then 1 over cosine, it's secant. So you have secant squared x here. So that's where this 1 plus tangent k was derived. Okay, so from secant squared x, you will have 1 plus tangent squared x. Other questions? So here, the power of secant, it's even. Now, if the power of tangent, that's m, is odd, okay, then m minus 1 is even. So what we're going to do, if you have this tangent to the mx secant to the nx dx, so you assume there is a secant there. Okay, you assume there should be a secant there. Of course, if there's no secant, you only have tangent to the mx dx, you can use your reduction formula, the one that we arrived at the beginning. Okay, So in the case where the power of tangent it's odd and there is also a secant, okay, what you're going to do is to extract one tangent and one secant. You extracted one tangent. What will remain, okay, after the extraction of tangent, you will have an even power for tangent. Okay? So you will save a factor secant x tangent x. And then convert the other tangents into in terms of secant. Okay? Okay? So this is what will happen. You have tangent to the mx, secant to the nx. You extract one tangent, so you will have tangent to the m minus 1x, and this is the other tangent. From your secant to the n minus 1x, whatever the power of secant, whatever it is, you also get one secant. So you will have secant to the n minus 1x, secant x. And this guy here, secant x tangent x, you save it. And then this guy here, tangent to the m minus 1x, the power of tangent is even. Okay, m minus 1 is even. You convert it to in terms of secant. So just like before, you rewrite tangent to the m minus 1x as tangent squared raised to m minus 1 over 2. So again, this is an integer, so we're good at that. And then we convert tangent squared x into secant. So everything will be in terms of secant except for this tangent. And this tangent, we will attach it to the secant here. So you expect the substitution should be u equals secant x. Okay? Let's put that into practice. You have here tangent to the fifth power x, secant cube x dx. You want to integrate that. So we will rewrite this as the integral. So we'll get one tangent and then we'll also borrow one secant from here. So we will have tangent to the fourth x, secant squared x, and then here you have secant x, tangent x dx. And then this tangent to the fourth, we will write that as tangent squared x quantity squared. And then you have your secant squared x, and then you still have your secant x, tangent x dx. And then tangent squared, this time now, we will use the identity. So tangent squared x, that's equal to secant squared x minus 1. And then you have that quantity squared, and then you have secant squared x, and then you still have the secant x, tangent x dx. When everything now is in secant except for this tangent here, okay? And we have saved the factor secant x tangent x. We can now start doing the substitution. U equals secant x du, this is just secant x tangent x dx. Which means we now have the integral of u squared minus 1 squared times u squared du. Now we'll just expand this guy here. So if we expand, we will have u to the 4 minus 2u squared plus 1 multiplied to multiplied to u squared, and then we have the du. We distribute the u squared. We will have u to the 6 minus 2u to the 4 plus u squared quantity du. And this will be integrable easily. So if we integrate, we will have u to the 7 over 7 minus 2u to the 5 over 5 plus u cubed over 3 plus the arbitrary constant c. And then finally, we will have secant to the 7x over 7 minus 2 secant to the 5x over 5 plus secant cube x over 3 plus the arbitrary constant c. So this is the final answer. Okay. Questions? Now, what if the first two conditions were not satisfied? Okay? Meaning, what if the power of secant is odd and the power of tangent is even? Because for this step here, we needed power of tangent to be odd. And then the other
Sir?
condition, you have the power of secant to be even. Okay? So what if they are not true? Okay? Yes, question?
Can you just go back to
Okay, so it's in here. So if that is the case, okay, if that is the case, we can hope that the power of tangent is even, not other numbers.
Thank you.
There's a possibility that the power of tangent could be rational. I mean, non-integers. Okay? Both secant and tangent. But we will not deal with those integrals, at least for now. So for here, we wanted the powers of tangent and secant to be integers. And if the power of tangent is even and the power of secant is odd, what we're going to do is to convert all the tangents into in terms of secant. Okay? So everything will be in terms of secant. No more tangent once you've converted the tangent in terms of secant. And then you'll just use the reduction formula. Okay? You'll use the reduction formula. Okay? So for example, you have here integral of tangent squared x secant dx. Okay? So this is an example where we cannot use the methods, the first two methods for this part. So what we're going to do is to convert this tangent squared into secant. So in here, we have the integral of 1, or we have the integral of secant squared x minus 1, and then you have the secant x dx. And then if we distribute this secant x, we will have the integral of secant cube x minus secant x quantity dx. We already know the integral of secant x. That's ln of something. Okay? So for us, we just need the integral of secant cube. We need the reduction formula. Okay? So let us go back to the reduction formula and let us apply that. You have this. Okay? Secant to the n x dx, that's equal to tangent x, secant raised to n minus 2x over n minus 1 plus n minus 2 over n minus 1 integral of secant raised to n minus 2x dx. And in our example, we have n equals 3. Okay? So let us write that. So for this guy here, we will have tangent x secant x over 2 plus 1 over 2 integral of secant x dx. And of course, you still have this minus integral of secant x dx. Okay? That's from the reduction formula. Okay?
Would we have to write out the proof every time, or can we just memorize it and then
You can
plug in
memorize
the-
it. You can
Okay.
memorize it. Unless, like I said earlier, unless I am asking you to prove it.
Okay,
But you can memorize it.
thank you.
You're welcome. And therefore, let's just combine this 1/2 secant x dx, okay, minus, sorry, 1/2 of integral of secant x dx minus integral of secant x dx. So this is just tangent x secant x over 2 minus 1/2 integral of secant x dx. And then let us now integrate secant x. So we will have ln, absolute value of secant x plus tangent x plus the arbitrary constant c. So this is the final answer. Okay? Other questions? Let's have another here. Integral of tangent to the fourth x secant cube x. So again, we cannot use 1 and 2. Okay? We cannot use the methods 1 and 2. So what we're going to do here, we convert tangent to the 4 into in terms of secant. So first step, you write tangent to the 4 power as tangent squared x quantity squared. And then in here you have secant cube x dx. And then in here you now replace tangent squared x as secant squared x minus 1 times, sorry, there's a square here, and then times secant cube x dx. And then you expand the square there, you will have secant to the fourth x minus twice secant squared x plus 1, and then you multiply secant cube x dx. And then you distribute secant cube x. So you will end up with this. Integral of secant to the 7 minus 2 secant to the 5th, then plus secant cube. Okay? And then you do reduction formula for each. Okay? You do reduction formula for each, and you will get the final answer. So for example, I'll just write this for the secant to the 7 first. For secant to the 7, we will have tangent x secant to the 5x over 6 plus 5 over 6 integral of secant to the 5 x dx. And then you have that minus 2 for this guy now. Okay? In fact, I'll not do this and this for the moment. So I will have minus 2 integral of secant to the 5th power x dx plus integral of secant cube x dx. What we can do is to combine this guy with this guy first before applying the reduction formula again. You see the pattern? So if we do that, if we combine them, you will have tangent x secant to the 5th power over 6 here plus you have here 5 over 6 minus 2. What's that? That's negative 7 over 6. So it's 5 minus 12. That's negative 7. So you have minus 7 over 6 integral of secant to the 7x dx plus integral of secant cube x dx. And then you convert, sorry, why is this 7? This is to the 5th power now. And then you use reduction formula in here. You will have something secant cube. You combine it here. And then again, use the reduction formula for the secant cube. And you will have secant. And then that's integrable already. So from here, I want you to continue. Okay? Continue. It will help you memorize your secant, your reduction formula for the secant. At least, that's what I expect. Okay? So again, I'll write it here. Integral of secant to the n x dx. This is tangent x secant raised to n minus 2x over n minus 1 plus n minus 2 over n minus 1 integral of secant raised to n minus 2x dx. Okay? Questions? for the other forms, this is what we want to integrate. You have sine mx cosine nx dx. We have integral of sine mx sine nx dx, or cosine mx cosine nx. So these are the things that we need to integrate, or the combinations that we want to integrate. Okay? We will need the following identities. Sine A cosine B, that's 1/2 sine A minus B plus sine A plus B. Sine A sine B, that's 1/2 cosine A minus B minus cosine A plus B. And you have cosine A cosine B, that's 1/2 cosine A minus B plus cosine A plus B. Yes? Question, Sophia?
Can you go to the previous example?
So it's in here.
Okay, so for this, we keep doing the same procedure until the first, like that first part is at, like doesn't have any more exponents, right?
Yes, until you will have sa integral of secant x.
Okay.
Possibly. Either you will have this at the end, or you will have secant raised to power 0 dx. So this is just secant dx, or the integral of dx.
That would happen if there was an odd amount, like an odd exponent, right?
Yes, it will
Okay.
happen when your n is actually even.
Oh yeah. Okay, yeah.
Okay? But again, if the power of secant is even, we have a specific technique to use.
Right.
So usually, reduction formula for secant, it's really helpful if you have odd power of secant.
Okay. Thank you.
You're welcome. So again, we have this for the other forms. So again, these identities, I hope you remember them from your trigonometry class. Okay? So we will use that. So what will happen is you have products of sine and cosine, or sine sine, or cosine cosine. When you do this, okay, you won't have products of sine and sine, or cosine and sine, or sine, or cosine and cosine. So the resulting right-hand side in here will be easily integrable. Okay? So, for example, integral of cosine 2x cosine 5x dx. If we use the identity, we will have 1/2 integral. What will remain inside? So let us go back. Cosine, cosine, we need this 3 here. So that's cosine AB plus cosine, cosine A minus B plus cosine A plus B. And we have a plus in here. So we will have here cosine 2x minus 5x plus cosine 2x plus 5x, quantity dx. So this simplifies into 1/2 integral of cosine negative 3x plus cosine 7x, quantity dx. But then again, cosine of negative x, that's just cosine x. So we will have here 1/2 integral cosine 3x plus cosine 7x. And if we integrate this is just 1/2 integral of cosine 3x. That's sine 3x over 3 plus integral of cosine 7x. That's sine 7x over 7. And then plus the arbitrary constant c. So this is the final answer.
Sir,
Yes.
can you re-explain how you got the negative out from
In here,
3x?
it's a property of your cosine. Cosine of negative x, this is always cosine x.
Okay, okay.
So that's why the negative just disappeared. That's for cosine. You might use this later. So sine of negative x, this is negative sine x. Okay? Sophia, your hands is raised.
Oh, sorry.
Okay. Okay. So I think this will be my last example for this lecture. Now we have sine 4x cosine 3x. So we have 1/2 integral. Sine and cosine. Okay. Sine and cosine here. So sine and cosine. So we will use this. Okay. So 1/2 sine A minus B plus sine A plus B. So in here you have sine 4x minus 3x plus sine 4x plus 3x. And then the dx in here. So if we simplify this, we have 1/2 integral sine x plus sine 7x dx. So integrating, we have sine, or 1/2 quantity, negative cosine x minus cosine 7x over 7 plus c. Okay.
Sir, sir,
Yep.
can you go to a previous slide?
So this slide in here.
The previous yes.
This guy here.